All right, now that we know the power rule, and if you don't know the power rule, you should watch that video first. But once you know the power rule, it turns out you can use that power rule to find the derivative of powers that aren't whole numbers. So it turns out the big trick is going to be to look at roots and just turn them into rational exponents, fractional exponents. Like x square root of x is actually x to the 1/2 power. Now, just a warning here. I'm only going to work these where there's x's under the square root. If it was a square root of x plus 1, we need the chain rule. You might not have gotten the chain rule yet, but if you have, and the problems you're working on require the chain rule, I would encourage you to not, you could still watch these videos because they'll be like the basics and how to do it initially. But then in the chain rule chapter, I'm going to basically redo all these videos, all the basic differentiation rules for polynomials and trig functions, everything, only with harder problems that need the chain rule. So keep that in mind. It'll turn out there's some tricks though, so we could have an x squared under here, x cubed, whatever. It'll turn out we can actually deal with that in this chapter. We don't need the chain rule for all of them. All right, so let's take a crack. So the first step is to put these things in fractional exponent form. So I just mentioned that x squared of x is x to the 1/2. Now a cube root of x is just x to the 1/3. Not too bad. Basically whatever number is here, and of course in a square root there's sort of like an unstated 2 right there, so that's how we got 1/2. Cube root is 1/3. And then this last one is sort of like the trickier one. Once again, the denominator of the exponent is going to be whatever's right here, so that'll be a 3. But then because we have a 2 here, that goes right there. The reason we got these 1s on these ones was because these are x's, kind of like, if you have x, you can sort of imagine there's a 1 up there as the exponent. You don't bother writing it down because it's so obvious, but there's a 1 up there, and there's kind of a 1 under there, or there's a 1 in front. You can sort of stick a 1 in almost anywhere, right? And it doesn't change anything. So that's where this 1 comes from in 1/3 and 1/2. But then as soon as you have an actual exponent, that becomes the numerator of your power. If this slide was confusing to you, you might want to go back and check out in Algebra 2. I've got a bunch of videos about exponent rules and about rational exponents, which will explain all this crazy, weird roots of weird exponents. All that'll be in there. All right, so once we've got them in fractional exponent form, we can take the derivative. All right, so we just said that this one would be x to the 1/2. The power rule still works. Even though we've got a fractional exponent, which seems kind of weird, the power rule is still exactly the same. You take the old power and move it down front, keep your x, and then take away 1 from the original. And I'm talking about 1. So the new exponent is 1/2 minus 1. And of course, you're going to get into fractions quite a bit here, but 1/2 minus 1 is a negative 1/2. All right, so that's your answer. And this particular one, just to show you, 1/2 times x to the minus 1 is actually 1 over 2 square root of x. Because x to the 1/2 is a root x, the fact that it's a negative 1/2 means it's downstairs in the denominator, and then the 2 right here becomes the 2 right there. So I only drew this one out in the fraction form just to show you kind of what's going on. These other ones will be weirder and you're less likely to see them written out. This particular thing where you have, for some reason in calculus, there's a lot of square roots. Either in the derivatives chapters or once you get into integrals, you'll end up still dealing with a lot of square roots. So the situation of having a negative 1/2 power is actually going to come up quite often, and that's why, and sometimes you'll see it in fractional form like this, so that's why I just showed you what that one means. The rest of these will probably be the same. So this was x to the 1/3, right? So the derivative, we just take that and put it out front. So we get 1/3 x, and then 1/3 minus 1 is negative 2/3. Pretty weird, pretty annoying. All right, what is this one? X to the 2/3. So we take the derivative of that. Again, move the exponent out front. So that's going to be 2/3 times x to the 1 minus 2/3, which is negative 1/3. These are wacky, right? All right, so that is the craziness. Let's see what happens with other stuff. All right, what if there's an x out front? Now, I didn't show you one of these, but if we just had 2 root x, again, power rule is really simple. It would just be 2 times x to the 1/2. So when we did the power rule, we'd keep the 2 out front. So we keep our 2, then it would be the 1/2, then it would be the x, then it would be negative 1/2. So of course this 2 would cancel that, and we just end up with x to the negative 1/2. So dealing with numbers out front, real easy. It's just like all the other power rule problems, okay? when you have an x out front, a little bit more interesting. You might look at this, if you've already gone a little bit past this in class, you might recognize this, hey, this is the power rule, Chris. How can you do something multiplied together? If that's what you're thinking, I like it. That means that you've already learning to spot the particularities of calculus and all the little rules and caveats you got to know by heart and be able to spot real quick. If you didn't spot that, I just told you, and now I'll show you how to deal with that. It turns out we can combine these because they're both powers of x, right? This is x squared, and the root x is just x to 1/2. There's this exponent rule where when you have the same bases with different exponents and they're multiplied together, we can add them. So it'll actually be x to the 2 plus 1/2, which is 5/2. Once you write it as x to the 5/2, you can see, oh yeah, that's really just your usual power rule deal. So it's 5/2 times x to the power of 5/2 minus 1, which is 3/2. Alright, so pretty gnarly, but the point is, if you can combine everything into one x with a single exponent, power rule is your friend. And we love the power rule because it's the easiest thing in derivatives. Alright, last one, we got x to the, I believe, what I meant by this was that it's a cube root of x. So this is x to the first power times x to the 1/3 power, which gives us x to the 4/3 power. And now we can take the derivative with the power rule pretty easily. So that goes down front. 4/3 x to the 4/3 minus 1, which is 1/3. So you can see now, maybe you're getting the hang of this, that if the original exponent's bigger than 1, like we had 4/3 for this bottom problem and we had 5/2 or 7/2 or whatever up here, that means that your derivative will also have a positive exponent. So that's one nice thing about improper fraction exponents, is that at least you don't have negative exponents in your answer, which makes it a lot easier to deal with if you're plugging in and stuff. Alright, last thing we'll do, just like with polynomials, the power rule, you can sort of apply it to each term separately. We can do the same thing with these things. So here we've got a bunch of fractional exponents, which of course, if I wanted to write this out, this would be like x root x. So really if you saw this in this would be x root x plus 2 root x plus 3. If they had given it in this form, we'd convert it to this with the fractional exponents. Then we do the power rule on each term one at a time. So 3/2 out front. So you get that first term is 3/2 x, and then 3/2 minus 1 is 1/2. Plus 2 times 1/2 x to the negative 1/2. And then what's the derivative of 3? Trick question. It's a constant. Derivative of numbers, or constants, is always 0. So we're already done at this point. I just want to combine that 2 and that 1/2. They actually cancel, I guess. So we get 3/2 x to the 1/2 plus x to the negative 1/2. Good stuff. And last one. Looks like we just go straight to the power rule. 4/3, old exponent out front, then x, then 4/3 minus 1 for our new power, gives us 1/3. Alright, what's the derivative of x? Anyone? Yeah, it's 1. Basically, you do the power rule on it and stuff. You put the 1 out front. You'll end up with x to the 0, which is just 1. So point is, whenever you have an x to the first power, its derivative is just whatever's out front, and which in this case is an imaginary 1. So not so imaginary anymore after you take the derivative. And plus 2 times old power, 2/3 x. 2/3 minus 1 is the negative 1/3. Alright, so now we just rewrite this. 4/3 plus 1 plus 4/3 x to the negative 1/3. And there you go. So the moral of the story is that the power rule is really easy to use and really powerful. Pardon the pun. So when in doubt, try and get whatever you're trying to take the derivative of to look like a power rule instead of whatever else you got. So for example, we had the x squared root x. That would require a product rule. The product rule, if you've seen that already, it's complicated. You take this one kind of simple thing and it turns into a whole mess of stuff. Much better if you just combine exponents to begin with and then can use the power rule, which is much simpler. So keep that in mind. When in doubt, whenever you're thinking about using the product rule or the quotient rule, see if you can maybe figure out a way to not use them and just combine things instead. Because the power rule is your friend, and it's the easiest way to take any derivative ever.